If you've spent time scraping the web with Python, you've likely used tools like Requests and BeautifulSoup. While these tools can do the job well, they might not be enough if you want to scale your scraping project. If that's the case for you, Scrapy might be just the tool you need. I'm Manfidus, and in the next 15 minutes, we'll build a web scraper with Scrapy and Python. So what exactly is Scrapy? Scrapy is an open source framework designed specifically for scraping the web on a larger scale. Unlike a basic library like Requests, it gives you a full toolkit right out of the box for scraping whole pages, no extra setup. For example, it handles crawling, following links across a site, while extracting data from each page. It's also made for sending out multiple requests asynchronously, resulting in great performance out of the box. Now that we know what Scrapy is, let's write our first scraper. For this, you'll need to have Python 3.9 or higher installed on your device. We'll also be using VS Code as our code editor. Begin by opening a VS Code page and starting up a terminal instance. In the terminal, run these commands to create and activate a virtual environment and install Scrapy. Then, create a new Scrapy project by running the Scrapy start project command like this. We'll call the project product_scraper. Once you have that, enter the newly created directory and create your first spider, which will crawl the provided website. For this tutorial, we'll be using the Oxylabs sandbox, which is a free-to-use e-commerce site created for practicing your scraping tasks. Therefore, let's name the spider Products. We'll also need to provide the URL for the page we'll be scraping. To do that, run this command. As you can see, Scrapy generated a bunch of files for us. Let's take a look at what's what. The spiders / directory is where the instructions for parsing each of your target pages live. We'll be defining our CSS selectors here shortly. You can define the format you expect your results to be in the items.py file, while the pipelines.py file defines what you can do with the data once it's scraped. This is usually used for validating the data or storing it in some database. The middlewares.py file allows you to intercept the requests by adding proxies or custom headers, while settings.py offers some project-wide configuration, like concurrency settings and delays. If you ever decide to use Scrapy's scrapyd deployment platform, you can check out the scrapy.cfg file as well. Now, let's jump into the spider for our e-commerce site. First off, let's look deeper into the site we'll be scraping to identify what we can use to select the product data. Let's open up the Oxylabs sandbox in our browser. Right-click on any product on the page and click Inspect. This should open up the DevTools console, showing the HTML content within the page. If we click on the cursor icon and hover on the products themselves, we can identify what attributes each element has. Let's say we need to scrape the title and price of each product. As you can see, the title has a title class within an H4 element. The price has a price wrapper class within a div, and each product is wrapped within a product card div element. Let's note selectors down so we can use them in our Scrapy spider. Now that we have our CSS selectors, let's open up the products.py file within the spiders directory of the project. Scrapy has already provided us with a blank parse function, which should yield the parsed out result of each page we scrape. To do that, we can use the CSS function of the response argument to perform a CSS query on the scraped page. Let's select each product card and iterate through it in a for loop. Within the for loop, we can try and find the title and price of each item, with the selectors discussed before. Let's form the result into a dictionary and yield it with each cycle within the for loop. This should give you a working example of scraping all products from a single page. However, it's likely you'll want the ability to scrape multiple pages. Since the sandbox exposes pages from a query parameter, then it's as simple as adding this one-liner within the start_URLs variable in your spider. You can adjust how many pages you want scraped by changing the numbers in the range function. Scrapy will loop each URL provided and go through your provided parsing logics each time. It's worth noting that other sites are likely to have a more sophisticated form of pagination, which requires extracting the link for the next page button. Such a scenario could be handled by Scrapy as well, but we'll stick to a simpler example for this tutorial. This should give us an initial working spider we can already run. To run our spider, type in this command within your terminal. We'll add the -o flag with a CSV file name to indicate that we want the output to be a CSV file. After it's complete, you should see a products.csv file in your project directory, containing a list of products with titles and prices. That's the way you'd usually use Scrapy to scrape a website, but there are instances where you might need to integrate Scrapy into an already working application. Let's take a look at how you can run your spider from a Python script. Let's create a new file called run.py. Within it, we'll need to import some things from Scrapy first. This includes a module for handling signals from Scrapy, the crawler process object for starting off the spider from code, as well as the spider itself, and the get_project_settings module, which reads Scrapy's settings and passes it into the process. Next, we'll define a main function where the script will start. To start the spider, we'll need to define a new process variable from the crawler process object, which is initiated with our project settings. We'll then create a crawler variable from our spider class, pass it into the crawl method, and start the process. If we run the script now, you can see that the same spider process is running as before. However, to gain more control over the scraping process, we can tell Scrapy to do something once it scrapes an item using the crawler's signals attribute. To do that, let's write a short function that prints out an item and connect it to the item_scraped signal within the crawler. This should tell Scrapy to print out the item once it's scraped. Let's run the script again to confirm. As you can see in the terminal, the titles of the items are printed as expected. To store the data in this approach as well, you can append each item to a new list called results and add these lines at the end to create a new JSON file from the scraped products. If we run this script again, a new JSON file with the same data as before should appear in your directory. And that's all for now. If you want to make your script even more robust, consider adding proxies to your Scrapy project, deploying it into Scrapy, or even handling JavaScript rendering with a headless browser. If you enjoyed this video, don't forget to like, subscribe, and make sure to check out similar content on our blog and YouTube channel. Thank you for watching, and see you next time.